Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over an example on how to solve polynomials of higher degrees using the factoring method. Okay, so in this problem, we're asked to solve the polynomial equation, this given polynomial equation by factoring. So before we get started, we're going to review two quick rules that can help us to factor this polynomial with ease, okay? So the first one has to do with the difference of cubes. Difference of cubes. Okay, so how do you factor a difference of cubes? Let's say you have a cubed minus b cubed. The factored form of a difference of cubes is a minus b times a square plus ab plus b square. Okay, the first sign in the factored state is always the same as the sign of the sum or difference of cubes. The second sign is always the opposite, and the last is always positive. All right, so you can keep this in mind. Let me show you the positive version too. So a cubed plus b cubed is equal to, first sign is going to be the same, a plus b. Second sign, a squared, is going to be the opposite of the sign here, which is negative, minus ab, and the last sign is always positive. Okay, so difference of cubes, and then also you have to remember the factorization trick for perfect square trinomials. Okay, there is a shortcut for factoring perfect square trinomials. So let's say we have a perfect square trinomial, a squared plus 2ab plus b squared. If you root the first and the last and bring down the middle sign, you have the factored state of this polynomial, which is a plus b quantity square. Okay? And then if you have a squared minus 2ab plus b squared, that factors into a minus b quantity square. Alright, so let's keep this in mind. Okay, so let's go back to the problem. If you want to factor this by, solve this by factoring, since you have four terms, the first thing that comes to mind would be to factor by grouping. Okay, so let's just try that and see if it works. So to factor by grouping, I group the first two terms and the last two terms. Now I'm going to factor out the GCF from the first two. X to the third minus 6x squared, the GCF, you have a 1 here. A 1 and 6 is 1, of course. And the GCF of x to the third and x squared is x squared. You pick the lower of the two exponents. So you have x squared times, now if you factor out a GCF, it's as though you're dividing these terms by the GCF. Okay? So x to the third divided by x squared is x. 6x squared divided by x squared is 6. Now over here, the GCF is positive 4. If you factor that out, you have plus 4 times 12x divided by 4 is 3x minus 8 divided by 4 is 2 equals 0. Now, anytime you factor and you want to check, you can always distribute to see if it's true, like x squared times x is x to the third, x squared times 6 is 6x squared, 4x times 3x is 12x, 4 times 2 is 8. So our factorization is correct. Now let's move on to the next step. Factoring by grouping. If this method were to work, these quantities in parentheses have to be identical. Are they identical here? The answer is no. So what does that tell us? Factoring by grouping ends up at a dead end right here. Okay, it doesn't really help us to factor this polynomial. Alright, so what we have to do is go right back to scratch. X to the third minus 6x squared plus 12x minus 8 equals 0. And we can basically inspect this polynomial and see, is there anything about this polynomial that can give us a hint as to what method can be used to factor it completely. Now if you take a look at the first term, you have x to the third, and the last term is 8. Now, if you think about it, what do these two terms have in common? These two terms are cubes. So that's a clue for you to use the sum or difference of cubes formula to attempt to solve, to factor this polynomial, okay? So let's try that and see if it works. So what I'm going to do is I'm going to group the first and the last, x to the third minus 8, and then the middle together, negative 6x squared plus 12x. Okay, now if you look at these two right here, we can cluster them together. What is this? This is a difference of cubes. Alright, so now that we've identified this as a difference of cubes, how do we factor difference of cubes? Okay, let me go over the steps for factoring difference of cubes on the right-hand corner right here. So there are 3 steps involved in factoring difference of cubes. Step number 1 is to write down the correct formula. Okay, write down the formula. It's kind of like your guide or like your map to help you factor it correctly. There are 2 formulas here, so you want to be careful to write down the correct formula. Step number 2, you want to find a and b. Okay, and lastly, you want to substitute and just basically substitute and simplify. Substitute and simplify. Some problems involve simplification, others do not. In this case, we are not going to have to do any simplification here, since a and b are just single terms, okay? Now, let's go ahead and apply the formula, the steps. So, first of all, we are to write down the formula. We are working with difference of cubes here. This is an equation setup, so the way I'm going to set this up will be slightly different. So since this is a minus, we're going to be using the difference of cubes formula. And this right here is this one right here is a sum. Sum of cubes. Okay, now the difference of cubes formula is a to the third minus b to the third. That's the left side. What does that simplify into? The right side is going to become a minus b quantity times a squared plus ab plus b squared. Okay? So step number 1 has been executed. We've written down the formula, although I broke it apart since I'll be filling the factors form underneath. Now let's find a and b. How do you find a and b? Now, x cubed and a cubed occupy the same spot, so we know that a cubed is equal to x cubed. That's the first term in the difference of cubes. Okay, now let's simplify that. How do you get a by itself? You use the inverse of cube, which is cube root. So you take the cube root of both sides. And what do we find out? We find out that a is equal to x. Alright? This cube and cube root are inverse functions or operations, so they cancel each other out. Now let's shift our attention to the determination of the b value. B cubed, the second term in the formula, is equivalent to or occupies the same spot as 8 in the expression to be factored. So we have b cubed equals 8. And to isolate b here, we take the cube root again, cube root, and this clearly tells us that b is what? B is 2 because 2 to the third power is 8. Okay? Now let me show you how to find cube root using a Texas Instrument calculator. So if you want to find the cube root, all you do is you take the number and then you raise it to the fractional exponent of the root you're taking. So since you're taking the third root, it's going to be raised to the parentheses 1 divided by 3. Okay? If you do not put the parentheses, your calculator will read the problem wrongly. Okay? So you have h raised to the 1/3, and the answer is 2. Now, let's say you did h raised to the 1 divided by 3, and you press enter. This is what you get. This is wrong because the calculator thinks you are raising h to the first power, which is 8, and then dividing it by 3. So that's incorrect. The correct way of entering the cube root is to group the power, the fractional power, in parentheses, press enter, and you get the cube root. Okay? Alright, so now we have a and b. We're going to advance to step 3, which is substitute and simplify. Okay? So a is what? A is x minus b, 2, times a squared, which is x squared, plus ab, which is 2x, plus b squared, which is 2 squared, 4. Okay? Alright, so that's that for the factorization of this difference of cubes. Now let's shift our attention to these two terms on the right. What is the GCF of negative 6x squared and 12x? The GCF is negative 6x. So if you factor that out, you're going to be left with x minus 2, okay, equals 0. Now what do you notice about the two sides of this expression right here? You notice that they have a common factor, namely x minus 2. X minus 2 is common. So what do we do with x minus 2? Since they're common, we factor it out, right? So we have x minus 2, and then we're left with this quantity right here, x squared plus 2x plus 4 and negative 6x. We group those two together in their own parentheses. So we have x squared plus 2x plus 4 minus 6x equals 0. Alright, now let's shift our attention here to this polynomial with 4 terms. Can I simplify? Absolutely. 2x and negative 6x are like terms. So we have x minus 2 times x squared minus 4x plus 4 equals 0. Okay? Now, if you inspect this closely, what do you notice about this quadratic trinomial? You notice that this is a perfect square trinomial. How do you determine that? Well, if you double the square root of the first term, x squared, and the last term, 4, do you end up with the middle term? What is 2 times x times 2? You get 4x. Is that the middle term? Absolutely. So this is a perfect square trinomial. So what does that mean? We can use this factorization trick right here to factor this trinomial. Okay? So that just involves taking the square root of the first and the last term and bringing down the middle sign. Okay, so we have x minus 2 times x, bring down the middle sign, minus 2 quantity square equals 0. Another way to factor this, you can use your nice little x game. Okay, if you don't know this factoring trick, factoring using the x game or the AC method works equally well. So AC goes on top, which is 4, and B is negative 4. The two numbers that work are negative 2 and negative 2. So the factored form of this would be x minus 2 times x minus 2, which is exactly what we have right here. Okay? So whichever method you want to use, you'll end up with the same result. So the completely factored form of this is we have x minus 2 times x minus 2 times x minus 2 equals 0. Or you can write it as x minus 2 to the 3rd power. Okay? Since I'm solving here, I'm just going to take one of the factors, x minus 2, and set it equal to 0. They are identical, so I don't have to do it 3 times, because that will yield the same result. To finish our problem solving process, we are going to isolate x. So simply add 2, and that yields x equals positive 2. Since there are 3 factors of x here, we are going to have x equals 2 with the multiplicity multiplicity of 3 because it shows up 3 times. So that's your final result. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found this tutorial beneficial to you, please give us a thumbs up. We appreciate the feedback. Do not forget to subscribe to our channel for updates to other tutorials such as this. If you have any questions about this example or the factorization of higher degree polynomials in general, just ask us your question in the comments section below, and we'll be glad to assist you as early as possible. More clips can be found on mathgotserved.com. Thanks again for watching, and have a wonderful day.